So we are still working with the same function f of x. This is the function in factored form. So we are going to use end behavior to determine if there is a horizontal asymptote. So first, let's think about x as it approaches negative infinity. So f of x would become infinity plus 3 times infinity plus 3 plus 1 over infinity plus 3 times infinity minus 1. Okay, these constants 3 and 1 and 3 and negative 1 are so insignificant compared to infinity that this really simplifies to infinity squared over infinity squared, which is 1. Okay, so as our graph goes to negative infinity, f of x, which is the same as y, goes to 1. Okay, so we are going to have a horizontal asymptote at y equals 1. Similarly, for x goes to infinity, I think we could see pretty quickly, this should have been negative. I'm sorry. But still, negative infinity times negative infinity would go to infinity squared, and negative infinity times negative infinity would go to infinity squared. So similarly, I can see that when I do plug in infinity, which I did by mistake above, I have infinity squared over infinity squared, which goes to 1. So I have that same horizontal asymptote, y equals 1. So there are 3 cases. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So let's think about an example for that. Let's say we have that our f of x equals x to the 4th over x squared. Okay, so our degree in the numerator, 4, is greater than the degree in the denominator, 2. So think about if we let x go to infinity, right? We would have infinity to the 4th over infinity to the 2nd, and that would go to infinity squared. Okay, so that means it's rising without bound. It's going up to infinity. Okay, so there's no horizontal asymptote. Our second case is if the degree of the numerator is less than the degree of the denominator, there is a horizontal asymptote at y equals 0. So let's think about that. Let's think if we have f of x equals x squared over x to the 4th. Again, if we let x go to infinity, we would have infinity squared over infinity to the 4th, which simplifies to 1 over infinity squared, which is really like 1 over infinity. 1 over an enormous number really goes to 0, right? Think about it. 1 over 10, very small. 1 over 100, even smaller. 1 over 1,000, even smaller. 1 over 1,000,000, even smaller. 1 over 1,000,000,000, even smaller, getting closer and closer to 0. Okay, so that's why we have our asymptote at y equals 0. If the degree of the numerator is the same as the degree of the denominator, there is a horizontal asymptote at p over q, where p is the leading coefficient of the numerator and q is the leading coefficient of the denominator. So let's think about f of x equals 2x squared over 4x squared. Okay, again, if we let x go to infinity, we would have 2 times infinity squared over 4 times infinity squared. our infinity squares drop out, so we get 2 over 4, which is 1/2. Okay, so our asymptote would occur at y equals 1/2. But think about it. Our leading coefficient was 2 for the numerator, 4 for the denominator. 2 divided by 4 is 1/2. Functions can cross horizontal asymptotes. Usually you'll find that away from the end behavior. And many times the y value where a horizontal asymptote occurs will be excluded from the range, but we can't determine the range until we've graphed the function. So where we were able to find the domain right away, we can't determine the range until we've graphed the function. So we've gone through a lot of work. Pause the video now. Try these 3 problems. Determine if there are vertical asymptotes, holes, and or horizontal asymptotes for the given functions. For any of these, if there is not a vertical asymptote, not a hole, or not a horizontal asymptote, you're going to write none. So pause the video right now. Come back when you've completed the work. Okay, if you need to, pause the video now and check my work. Make sure it matches your work. If you have any questions, please come and see me. Slant asymptotes have the form y equals mx plus b. Okay, linear functions that have a slope of m and a y-intercept of b. They only occur if the degree of the numerator is 1 more than the degree of the denominator. To find the slant asymptote, divide the numerator by the denominator. The slant asymptote is the line y equals the quotient, ignoring the remainder. So we're looking at a new function compared to our other examples. So I have f of x equals x squared minus 2x minus 3 over x minus 1. Okay, I can see that this is going to factor into x minus 3 and x plus 1. Okay, this is over x minus 1. Okay, so my factor x minus 1 only occurs in the denominator. So I have the vertical asymptote x equals 1. Okay, and I can see that here on my graph. I don't have a hole, right? Because I don't have a factor that occurs in the numerator and the denominator. This function has the slant asymptote y equals x minus 1. So here's the y-intercept of -1. It has a slope of 1. Rise 1, run 1. Rise 1, run 1. And the way we found that slant asymptote is we did x minus 1 divided into x squared minus 2x minus 3. So pause the video quickly and perform this operation. So when I perform that division, see how my quotient is x minus 1? So that's why my slant asymptote is x minus 1. It doesn't have to do with our divisor, okay? And they can be the same as it shows in this case, okay? But it's not y equals the divisor. You have to perform this long division. Okay, so I would like you to determine which of the following functions will have a slant asymptote. So pause the video for a second and pause it and decide. Remember, in order to have a slant asymptote, the degree of the numerator has to be 1 more than the degree of the denominator. So remember, the degree is the degree of the leading term. So this is degree 1 in the numerator over degree 2. Okay, the denominator degree is bigger, so that is not going to have a slant asymptote. Here in the numerator, the degree is 3, the denominator is 1. Okay, that's the degree in the numerator is 2 more than the degree in the denominator, so no slant asymptote there. For h of x, the degree is 3, the degree is 2, the degree in the numerator is 1 more than the degree in the denominator, so h of x is going to have a slant asymptote. In our last example, k of x, the degree are equal, degree 3, degree 3. Okay, so not going to have a slant asymptote. So now we want to perform the division. We want to take x squared plus 2x plus 1 and divide it into 3x cubed plus 2x squared plus x plus 1. So pause the video now and complete the long division. So I got the quotient was 3x minus 4. The remainder was 6x plus 5. We are going to ignore the remainder, and we're going to use the quotient to write the equation of the line. So the slant asymptote is y equals the quotient 3x minus 4. So important to know, functions can cross slant asymptotes, but the slant asymptote helps to predict the end behavior. Okay, if we look at our graph above, the graph is approaching at infinity the line 3x minus 4. So we could use it as an estimation if we were looking for a really large value. As always, if you have any questions, please bring them to class.